welcome back to another video with Indigo Math. Now we're going to see the properties of a square and a rhombus in this question. Let's start. It says here, PQUW is a square. So if it's a square, I know that all angles in the square are going to be 90 degrees. And you see, I've got a line QW here. I'm going to highlight that in yellow. This line here cuts the square exactly into half. So this tells me that your angle QWU would just easily be 90 degrees divided by 2, which is 45 degrees. So I'm going to mark that out here. This is 45 degrees. Next, it says QRSV is a rhombus. So QRSV is a rhombus. Let me now highlight the rhombus in green. So this one here is a rhombus, QRSV. And your rhombus is actually like a slanted square. And do you see the angle QRS is 70 degrees? And do you see you've also got a diagonal here that cuts the rhombus exactly into half? So that means your angle QRV would just simply be 70 degrees divided by 2, and that gives 35 degrees. These are just properties of a rhombus. Now, another thing about rhombus is you realize the opposite sides are parallel, right? Which means QR is going to be parallel to VS. If I've got that to be parallel, then I could use this angle property here. Remember the Z shape? I would just draw it out here at the side. If I've got the Z shape here, I can say that this angle that I'm shading in blue is equals to this other angle that I'm shading in blue, and this is the angle property, the alternate angles. So every time you've got parallel lines, you need to be very mindful of these angle properties. So if I've angle QRV to be 35 degrees, let me just mark this out here. Going by alternate angles, since QR is parallel to VS, then my angle RVS is also going to be 35 degrees by alternate angles. So I'm just going to mark this out here to be 35 degrees. I have one more piece of information that I haven't used in the question. It says, I'm going to highlight in yellow, that QW is parallel to RT. So let me just do that highlight in red. QW is parallel to RT. If these two lines are parallel, we could also use this other angle property called interior angles. So it's like that U-shaped one. So I'll show you one as an example here. If I've got two parallel lines, then let's say this angle here is A, this angle here is B. So you know that the angle at A plus the angle at B will add up to give you 180 degrees, and this is called interior angles. Again, it's got to do with the U shape. Since I have angle QVU to be 45 degrees, by interior angles, I can also say angle VTR is 180 degrees minus away the 45 degrees, and that's going to give me 135 degrees by interior angles. So I'm going to mark out all these. Okay, this one here is going to be 135 degrees. Now you see the question wants us to find angle VRT. So if I want to find angle VRT, let me just mark it out in blue highlighter. It's this little piece here. So do you realize actually this one here is part of a triangle VRT. And we know that the sum of angles in a triangle is 180 degrees. If we have already got two of the angles known, all I need to do to take is 180 minus those two angles, and I'll get the last angle. So let's do the last step now. To find angle VRT, I would just need to take 180 degrees minus away the 35, which is the RVS, and minus away the 135 degrees. That would give me 10 degrees, and the angle property is called angle sum of triangle. So this is just a quick recap of all the angle properties put together in questions where there are shapes like squares and rhombus, where you need to use properties of those shapes to help you to identify parallel lines so that you can do the question. Math really isn't just about practicing questions. Come join us for some fun events where we'll show you how math is actually very, very chill. See you soon!